Hi everyone. In this video, we are going to learn new topic, recursion. Recursion is one of the most efficient problem-solving paradigm which is used in many applications. Before jumping into the definition, let's see what is recursion. How do we apply this recursive algorithm in solving the problems? I have taken a small game. So the problem statement is you are given n objects whose weight is unknown and you are given double pan balance, which is useful to compare the weights of the two objects at a time. So one object we will keep it in this and another object we can keep it in this. So there are three possibilities, right? One is if both weights of O1 and O2 are equal. So then it will be balanced as it is, something like this. And O1 weight is more than O2 or O2 weight is more than O1. So the other possibility is O1 weight is more, then O1 will be down and O2 will be up, right? Another possibility is this case O1 weight greater than O2. So another possibility is O2 weight is more than O1. So these are the three possibilities, right? This case O2 greater than O1. So this is O1 equal to O2. So these are the three possibilities. So it is given that at a time you are able to compare two objects. So out of these objects, which is heavier object, we have to return. So let's try to understand the rules once again before solving the problem. So first rule is we are not knowing the weight of the each object. Weights are unknown. Second rule is at a time we can compare only two objects. So able to compare only two objects at a time. Okay, so then how we will able to find out which is the heavier object in the given list of n objects. Let's see how we will solve this problem. So assume that n equal to 8 means we are given 8 objects. Let's assume objects are O1, O2, O3, O4, O5, O6, O7 and O8. So in these objects we need to find out which is heavier one. That is the task given to us. So because it is given that at a time only two objects we can compare using double pan balance, right? So whenever we do compare, these are the possible states we will get it. Assume that one is always heavier than other object. Let's assume that for simplicity, we don't have any choice, like both the objects are equal. So then how we will do? We can do like we'll take only O1 and O2, right? And then O3 and O4, then O5 and O6, because at a time only two objects we can compare. So I'll compare O1 and O2, O3 and O4 separately, O5 and O6 and O7 and O8. So from this I found O1 is greater, and from this set I found O4 is greater. Just a rough assumption. From this I found O5 is greater, from this I found O7 is greater. So again, now we got how many objects we got after doing this operation? Now we are having only 4 objects with us, right? So again, compare O1 and O4. These two are one set, and O5 and O7. These two are another set. So in this I found it O4 is heavier. In this I found it O7 is heavier. Then again we have another set of objects which are O4 and O7, right? Again we have to compare these two objects because we are allowed to compare two objects at a time. So comparing O4 and O7 is possible. So assume that in this set we found O7. So that is nothing but O7 is the answer, right? So once again, let's see what we have done now. So in this, we are trying to divide the bigger set of problem into smaller set of problem. So because the here size is n equal to 8, we are not able to compare all 8 objects at a time because we have the limitation that we are able to compare only 2 objects at a time using this double pan balance. So what we try to do, we try to split our problem into smaller subproblems. So let's assume that at a time I am splitting the given set of objects into two sets. So let's try to break exactly half, equal size. So now what we got? O1, O2, O3, O4, one set, O5, O6, O7, O8, another set. So this is now, these two are now two subproblems, right? For the, which is of same type as the given problem. Here also, we have to find out among these objects, we have to find out which is heavier object. Again, in this subproblem, we have to find out which is the heavier object. But again, the size is 4. Means again, we are not able to compare all 4 objects at a time. So we try to split this problem again into subproblem. So then what it will become? We are going to split it. So O1 and O2, one set, and O3 and O4, another set. From this, O5 and O6, one set, O7 and O8, another set. So that is nothing but we have arrived into this situation, which we have thought that, okay, let's compare only two objects at a time. So now, is it possible to solve? Yes, it is possible to solve because we are able to compare two objects at a time, right? So this one we found answer as, here what we have considered as O1, and in this we found answer as O4, and in this we found answer as O5, and in this we found answer as O7. So then again we are combining the solution. So from this subset I found one answer, and from this subset I found another answer. Using these two answers, subproblem answers, right? Solution of these two subproblems. Again, I am trying to combine what is the solution for this particular problem. We are going to compare these two objects is nothing but we are trying to find out which is the heavier object in this particular subproblem, right? So in this what we have considered O4 is heavier, right? So O4, and in this what we found O7. So then we found solution for this subproblem and this subproblem, right? Then we have to combine these two solutions to find out which is the heavier object. Then automatically we are going to get solution for bigger problem which is given to us. So to summarize this, what we have done, we have divided the given problem into subproblems until when we are able to get the solution of the subproblem easily. So when n equal to 2, we are able to find the solution just by comparison using double pan balance in this case. So until n equal to 2, we further divided the given problem into multiple subproblems. So this is called, till here whatever we have, this is called divide step. And after that, once we found the answers, right? Once we found these answers, then we started combining it. So this is called combining step. So this is like a divide and conquer approach, and recursion is being used to solve this particular subproblem. So once we are dividing the subproblem, we are calling the same type of problem again and again. That is called recursion. So now let's write what is definition of recursion. By understanding this, just by looking at this, just we'll convert into the words. So it is a way of solving the given problem via solutions of the subproblems. So we have divided the given problem into subproblems until the subproblem is good enough to solve it. So in this case, n equal to 2. So the definition is recursion is a way of solving the given problem via solving the smaller versions of the same type. So here, if you notice it, the given problem and subproblem are of same type. So we need to find out heavier object, but just there is a change in size. That is called recursion. So now let's see what are the different rules before applying the recursion algorithm. So for recursion, whenever we are applying recursion algorithm, we need to make sure that how to divide the given problem into subproblems, right? So that is the recursion relation. And when do we need to stop dividing process? So at this point, we are stopping the dividing process, right? That is nothing but when n equal to 2. So this is called base case. Based on these things, there are few rules. Whenever we are applying recursion, there are few rules we have to make sure. So the rules are, so first one is recursive algorithm must have base case, right? When do we need to stop the dividing part? Just dividing the given problem doesn't make any sense. Are we able to solve by dividing the given problem? Means there should be some state change towards base case. So second one is must change its state and has to move forward its base case. So third one is even the subproblem should call the same function itself. Then only it is a recursive relation, right? So even the subproblem and the original problem should call the same function itself. So same example. Now let's try to apply on an array. So you are given an array of n integers and you need to find the maximum element. Let's consider we are given an array of 8 integers, n equal to 8, and we need to find the maximum element. Usually how we will do, like iterative mode, first we will initialize max to some lowest value, right? So like -1, or suppose if array is containing even negative elements, then in case of Java we can initialize using integer dot min value. Then what we will do, we just iterate to the array and we will compare with maximum, right? So for int I equal to 0, I less than size, which is 8, and I plus plus, we just compare it, right? So if max less than, here array is given as a, assume that ai, then so max has to be updated to ai, right? So like this we'll proceed, and at the end we are going to get what is the maximum element in the array. So this is the maximum element in the array, right? So now instead of doing this, whatever we have applied, so the problem is exactly similar to this, right? But we have taken, just to understand, we have given a constraint that weights of the objects are unknown and we are given double pan balance, right? So that is the only difference between this problem and the finding the maximum element in the given array. So now let's try to apply the same algorithm for finding the maximum element. So this is obviously one solution which we solve it using iterative method. So now let's try to apply the same algorithm whatever we have done here for solving the maximum element in the given array. So this is the array which we have taken. So this is our input, which is actually original problem which we have to find the maximum element. So first step, what we will do, we try to split the array into two parts. So first part we will get 5, 17, 2 and 71. Second part we get 4, 8, 91 and 13. We have to move towards base case, right? Which is when n equal to 2. So again divide the array into two parts. Now 5, 17, 2, 71. This case 4 and 8 and 91 and 13. And then we arrived n equal to 2 case. Means we are able to find the answer. What is the answer between these two? 17, and between these two 71. Between these two it is 8, and between these two it is 91. Then again we can combine the solution of this problem and this problem, right? So solution is 17, this is 71. So combining, then it is going to be 71, and combining, this is going to be 91. Then again we are going to combine the solution from 71 to 91, which is 91. From here to here, concurrent combine step. So now let's write code for this. Here I am using Java programming language, but once you get this concept, you can write programming in any language. So let's define a method which is, so here int find max, and we are given one is integer array a, right? So once we are given integer array, what we have to do? First we have to, so we are dividing the array, means we should know what is the start index and end index, right? So we will define one more method, find max, which will take a, and then start index here is starting 0 and end index is 7, right? Because here, okay, a dot length -1. So this is the recursive relation which we have to define. Define the method int find max. So we are going to get integer array here, which is a, and then int start, which is start index, and int end. So here we are assuming that when array is of size 2, we are able to compare, right? So first thing is we are dividing the array. So here start index is 0 and end index is 7, right? And we are dividing the array exactly at middle point, right? Every time we are trying to split array into two equal parts. If array length is of odd, then one array will be having one element more than another array. So let's try to find out the mid, which is actually, this is the mid index, right? So how we compute mid index? Usually start plus end divided by 2. So let's try write int mid equal to start plus end divided by 2. Then what we are doing? We are trying to get maximum element of this array and this array, right? So assume that this is left array and this is right array. So int left max equal to, now we have to find out maximum element in this array. What is the range now? Find max, it is going to be the sub problem, right? And we are going to use the same array, but starting index is, there is no change, and end index will be till mid. Calculating right max, right? So right max also same way we are going to call find max and a, and then range will be mid plus 1 to end. Okay, so once we get these two, then we are going to compare left max and right max, and finally we are going to return the maximum element. So if left max greater than, so how do we compare left max greater than right max, return left max, right? If this is not the case, means right max is the one, is our answer. So return right max. So when n equal to 2 is nothing but, because we are splitting the array using start and end, right? Start plus 1 equal to end, because this is start means this is end means start plus 1 equal to end, right? So if start plus 1 equal to end, then we have to compute the same thing, we have to do the same thing. So this one, let's assume that we are written in a method called max n1 comma n2. So here we compute. So that case we are going to call the method max a start plus 1 comma a end, right? And you know, here we achieved only two elements, right? But suppose for example, if array is of size 3, for example array size is odd number, let's assume for example we have elements in the array 17, 1 and then 13. So 2 plus 0 divided by 2, which is 1. So this is going to be split into 17 comma 1 and then 13, right? So here start plus, if this is not the case, means there can be possibility that only one element in the array. That means both start and end is same. So we have to write one more base condition. If start equal to end, then we have to return. So in this case we have to return, right? We have to return either a start or a end. Both are same only, right? So this is one more base case. The method call is exactly same, just there is change in start and end. This is the state change, right? There is change in start and end. So we are calling the same method again and again until we get one of these base conditions, and finally we are combining the solution. So here we got the solution and then we are combining the solution. So this is how recursion works. So here I'll list down some of the examples where we apply recursion algorithm. So one is binary search, and we use it in merge sort algorithm. Mostly tree traversal algorithms, we use recursion algorithms. So finding the max element in the array, we solved using iterative way, which is just traversing through the array and then finding the maximum. Another one is recursion approach, right? So I hope this video is helpful to you. Thank you for watching. Stay tuned. Happy learning.